Hello, good morning students. My name is Balram Reddy and look here my experience. Previously I worked in Maharashtra in Shraddha Institute of Career Development. It is in Ichalkaranji, and also I worked in Narayana Junior College in Andhra Pradesh and Royal Academy in Bangalore, and also JPIS in Kanke district in Chhattisgarh. Okay, look here. Today we are going to be discussing about the universal logic gates. Basically, there are the two universal logic gates are present. One is NAND gate and another one is the NOR gate. Why we are saying this NAND and NOR gates are called the universal logic gates? Why? Because by the repeating use of either the NAND gate or the NOR gate. By repeatedly we can construct the any gates such as OR gate, NOT gate, AND gate, XOR gate, XNOR gate. That means by the repeating use of any NAND gate or any NOR gate, by repeatedly we can use and we can construct the any gates. Such way we can call NAND and NOR gates are called the universal logic gates. Now look here. Now we are going to be discussing about the NAND gate. In general, this NAND gate is the combination of, look here, this here we are and N. This is the combination of AND gate and the NOT gate. This NAND gate is the combination of AND gate and the NOT gate. Look here, here is AND is present and N is not. Okay, and NOT gate. Okay, this is the NAND gate. Now the symbol, look here, the symbol. AND gate, the symbol, we all already know that this is a straight line and like this. This is the AND gate and the NOT gate. We have know that NOT gate symbol is like this. Okay. By the combining this one, if you think this is A and B are the inputs for this AND gate, and Y dash is the output, and Y is the final output. Okay. Now tell me what is the output of the Y dash? AND means just like a multiplication. That means A dot B we are getting, and this is NOT means for this whatever the input we have put the complement. That means AB whole bar. Okay. Now look the NAND gate symbol. NAND gate symbol. First of all, I am putting the AND gate. Okay. And the NOT gate, no, NOT gate means just I am taking the bubble. I am taking this bubble and then I am putting. This is the symbol of the which gate? NAND gate. And Y is equal to what is the output? AB whole bar. Y is equal to AB whole bar. Now look here the Boolean expression of this NAND gate. What is the Boolean expression we have got? Look here, Y equals to AB whole bar. This is the Boolean expression. Now truth table. Now the truth table. Truth table of the NAND gate. Okay. In the truth table consisting of the inputs and the corresponding outputs. Look at the inputs. What are the inputs we have present? The inputs are A and B for this NAND gate. A and B are the inputs, and what are the outputs? Okay, first of all we can take for making this one. Okay, first to take AB, Y dash is equal to A dot B, and Y is equal to AB whole bar. Y equals to AB whole bar. Okay, if it is the two inputs means we have know that what are the combinations we are getting, the inputs, what are the combinations? 0 0 1 combination, 0 1 1 0 1 1. These are the combinations we will get. These are the combinations we will get. Look here, first the AND gate, no, Y dash is equal to A dot B. That means Y dash is equal to A dot B. A into B. That means look here, A dot B means A into B. 0 into 0, we get 0. 0 into 1, 0. 1 into 0, 0. 1 into 1, 1. 1 into 1, 1. Now look here. Now Y is equal to AB whole bar. For this AB, we have put the bar. No, that means bar means not get means what? 0 means 1, 1 means 0. We will get. That means this AB here is the bar. 0 means what you are getting? 1. Bar means complement. Complement means 0 means 1, 1 means 0. And 0 means what? 1. 0 means 1. 1 means what we are getting? 0 we are getting. This is the truth table. Now how can we define this NAND gate? How do we define the NAND gate? For the definition, simply look here. Simply simple definition we can give. Okay, look here. Look here. These are the inputs and this is the output. Look here. AB is the input. A and B are the inputs. AB whole bar is the output for the NAND gate. No, these are the inputs and this is the output. Now look here. If 0 0 1 we are getting, 0 1 we are getting the 1, 1 0 we are getting the 1, 1 1 means we are getting the 0. Simple definition is if all the inputs are high, if all the inputs are high, output is 0, output is low. If all the inputs are high, output is low. This is one definition. Otherwise, if any one of the input is low, if any one of the input is low, what happens to the output? Output is high. Output is high. This is another definition of the NAND gate. Now we are going to be looking for the NOR gate. In the similar way of the NAND gate, NOR gate. In general, this NOR gate is the combination of the OR gate and the NOT gate. Look here, OR gate and N means NOT gate. This is the combination of the OR gate and the NOT gate. Now look here, we have already noted that the symbol of the OR gate is, look, this is the curved one and this is the symbol of the OR gate. Okay, and the NOT gate. The symbol of the NOT gate, what is the symbol? This is the NOT gate symbol. Okay, if A and B are the inputs, what is the output? OR gate means it is just like an addition. So we can get as y dash is equal to A plus B, just like an addition. Okay, so A plus B. And the NOT gate means we have to put the complement, whatever the thing we have put. Y is equal to, for this input, just you have to mention the complement. Now I am making the symbol of the NOR gate. I am making. First of all, what is present? OR gate is present. OR gate is present, and then NOT gate. NOT gate means just I am taking the bubble. Okay. A and B are the inputs. Y is equal to, what is present? A plus B whole bar. Now what is the Boolean expression? What is the Boolean expression for this NOR gate? Y equals to A plus B whole bar. Y equals to A plus B whole bar. This is the Boolean expression. Now look the truth table. In the truth table, what are the things are present? Inputs and the corresponding outputs are present. Okay, now look the inputs. What are the inputs are present? A and B are the inputs. Okay, and the outputs. Look here, outputs. Okay, first output is y dash is equal to A plus B. Y dash equals to A plus B. And another output is what is present? Y is equal to A plus B whole bar. This is another output. Now look here, if there is a two inputs, what are the combinations we are getting? Please tell me what are the combinations we are getting. One is 0 0 and another one is 0 1 1 0 1 1. These are the combinations we will get. Now look here, this is R. R means just like addition. 0 plus 0, how much? 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1. If all are high means we can get the high only. If all are high, we can get the high. Okay. Now for this A plus B, here is A plus B whole bar. Complement. Complements means what is getting? 0 means 1, 1 means 0. Here is 0, we are getting the 1. 0, 1, 0, 1, 0, 1, 0. Now tell me how can we define the NOR gate. Now how can we define this NOR gate. Definition of this NOR gate. For this, okay, NOR gate means A B is the inputs, Y is equal to A plus B whole bar is the output. No, this is the final output. Now look here. If all the inputs are low, if all the inputs 0 0, all the inputs are low, output is high. Output is high. This is one definition of the NOR gate. In the other definitions, if any one of the input is high, if any one of the input is high, what is the output? Output is low. Output is low. If any one of the input is high, output is low. If all the inputs are low, output is high. This is another definition. Now look the previous year questions. Based upon this NAND and the NOR gates, universal gates, we will see some of the previous year's questions. Look the JEE 2019 question. JEE 2019 question. They have given in such a way that one NAND gate they have given, one NAND gate they have given, and also they have given these are also the NAND gates only. These are also the NAND gates. Okay. They have given as A, B are the inputs and Y is the output. Okay. They are asking that which of this gate, okay, either the OR gate, B AND gate, C NOR gate, D NAND gate. Which of the following gate this one? For this, a simple trick if they given like this. Okay, if this is a AND gate, we have already known that this is the AND gate. Okay, bubbled AND gate. That means bubbled AND gate means okay, both sides. Okay, this side is bubble and this side is bubble and this side. Input sides are bubbles, output sides are bubbles. Okay, this bubble AND gate simply we call as a OR gate. Bubble and no, we call as a OR gate. In similar way, if you take the OR gate, okay, I am bubbling the both sides. I am bubbling the both input sides and output sides. This bubbled OR gate, this is the OR gate. No, we can call as a AND gate. AND gate. Okay, look here. In general, this is the AND gate. And output side is bubble is present, and the input side is also. Simply, we can call this gate is a single input. No, single input NAND gate we call as a NOT gate. Okay, NOT gate. This is bubble. Okay, here is, and here also bubble. Okay, input sides are bubble, output sides are bubble. So we can call as bubble AND gate means OR gate. Okay, look the proof also we can give. Okay, this is the input A to the NOT gate. Okay, input A to the NOT gate we are getting A bar. Okay, B to the NOT gate. What we are getting? B bar. Okay, and A bar and B bar are the inputs to the NAND gate. NAND gate means what we are getting? NAND gate output. First of all, we have to multiply whatever the inputs they have given. We have to multiply. Okay, and then we have to put the bar. Okay, and now first is AND is present. AND means the inputs we have to multiply, and NOT is present. NOT means we have to put the complement. This is the output. Now look here. Now by the De Morgan laws, we have the De Morgan laws. Okay, what they have given? If A plus B whole bar is equal to, if this is the addition and the bar means just we have to put the bars, we have to multiply and put the bars. Otherwise A into B whole bar means what they are saying. If this is the multiplication, just we have to put the addition and then A bar B bar. These are the De Morgan laws. In the similar way, here we have to apply. Here is the multiplication and the bars. Okay, that means you have to put the plus and whatever the things they have given, just you have to put the complement. Okay, this is B double bar. Bar gets cancelled. Then we are getting as A plus P. We have get as Y is equal to A plus P. This is plus means what? Addition. Addition means which gate? OR gate. So this is the OR gate. Okay. Now look the other questions. Okay. Look the neat no, no, no. Neat 2017 question. Look here. Neat 2017 question. They have given one NAR gate. They have given one NAR gate. Okay. And another one NAR gate they have given. NAR gate followed by the NAR gate. Okay, NAR gate. Okay, this is the two input NAR gate. This is the single input NAR gate. Okay, then which are the following gate? This one. They have given that R gate, B AND gate, C NOT gate, like this. D NAND gate. Which of the following gate they have asked? Okay, for this how can we do? Okay, first one, this is R, this is the NAR gate. We have know that this is the NAR gate. Okay, this is what gate? Okay, single input NAR gate means which gate? NOT gate. Okay, just bubble is bright, no, single input. Okay, here is the two inputs means NAR gate. Single input NAR gate means NOT gate. Okay, first of all, look here. Let us think this is y dash and think this is the output is y. Okay, and what we get? Y dash means what we are getting. Look here. This is R and the NOT. Okay, first of all, R means we have to addition. That means A plus B. And NOT means not means bar. Okay, here Y dash means first of all addition, no, A plus B, and then NOT means bar. Y dash means A plus B whole bar. Now, now, now what happens to this one? Okay, and then this is the NOT gate, no, just we have to put the complement. That means A plus B whole bar. This is already present, and the complements means double bar. That means y, what we are getting, y is equal to A plus B whole bar and double bar. I have already now itself you have seen the problem. If there is a double bar means double complement means just you have to cancel it. Then what we are getting, y is equal to A plus B. Then tell me which gate this one. This is R gate. This is the R gate. Okay. Now look here. Now look some of the problem. Okay, this is the AIMS 2005 question. AIMS 2005 question. Now look here, they have given which of the following gate is a, which of the following gate is universal logic gate. Okay, they have given is AND gate, options AND gate, B OR gate, C NAND gate, D XOR gate. Now tell me, universal logic gate means what? By using a single gate, we can construct the any other gate. Okay. Now we have already discussed only the two universal logic gates are present. One is NAND gate and the NOR gate. Okay, AND gate no, OR gate no, NAND. Okay, XOR no. Okay, NAND and NOR gates are the universal logic gates. So C option is correct. Now look the another problem. Okay, they have given this is in NEET 2016. The question is from NEET 2016 question. Look here, they have given the question like this. AND gate is followed by the NAND gate. AND gate is followed by the NAND gate. The inputs they have given as A, B, C. Output is Y. Output is Y. Okay. For all the inputs are high. For all the inputs are high. Output is what? Okay. Output is okay. Okay, if all the inputs are high and all the inputs are low, all the inputs are low, Okay, respectively output is. Okay, first of all they said that if A, B, C all inputs are high, what is the output? I, Y, and if all the inputs are 0, 0, 0, what is the output? Now tell me, here is, first of all I am taking the all the inputs are high. Now tell me, this is what we are getting, this A, B, A into B, we are getting here is, and means A dot B. Okay, this is the C. Okay, this is what, this is the NAND gate. This is what, this is the NAND gate. So what we have to do? First of all, we have to do the multiplication of these things. That means A dot B, okay, into C, and then we have to multiply this all the things, and then we have to put the complement. No, so what we are getting, Y is equal to A B C whole bar we have got. Okay, now take if first thing is, first condition, if all the inputs are high, they have given no, Y is equal to, high means 1 into 1 into 1 whole bar. Okay, 1 into 1 1, 1 into 1 1, that means 1 bar. 1 complement means what we are getting, 0. B, and the second condition we are taking, Y is equal to, and all the inputs are low, that means 0 into 0 into 0 whole bar. What we are getting, 0 into 0 0, 0 into 0 again 0, that means we are getting a 0 bar. 0 bar means 1, that means they are given like this options, A is 0 comma 1, B is 1 comma 0, like this they have given, C and D they have given. So which option is correct? 0 comma 1 is the correct option. Okay, thank you very much.